Okay, so welcome to everybody, and it is our pleasure to see all of you from a list of countries all over the world to join this webinar that is organized by ISPP Seed Pathology Committee, and I thank the speakers that accepted the invitation to share their expertise. They are very high-quality speakers, so Michael Fluken and Jairam Lamichan. But this meeting, the webinar, was organized together to ISTA, ISF, and IPP, that is Italian Association for Plant Protection. And we know that there is, at least in Europe, but I guess all over the world, a restriction toward the use of synthetic pesticides. So we have to use at best, because there are increasing problems that we need to solve. And the pathogens that are on or in the seeds can be used as a trade barrier. So on one side, we have to use as less as possible pesticide, but on the other side, we need to go toward a high quality seed. So to join those two needs, I think we need a lot of work, we need a lot of research, and we need a lot of dissemination. So this is one of the moment of dissemination, and I'm pretty confident also for one of you that will join the ECPP Congress in Lyon. There will be several sessions and satellite meetings on this subject, so this is a pretty good subject. And I give the floor to Rosa Sous Richards that will take a welcome for ISF. Rose, okay.
Hello, everybody. It's very nice to be here. Thank you so much, Gianfranco, for the invitation. And it's great to be talking about such an important subject for all of us, and very much important for the International Seed Federation and its membership. Because it's important to highlight to everybody that food is the most fundamental of all human needs. And today, producers all over the world face a huge dilemma. Demanding for food continues to increase. So while the land available for productive farmland is still shrinking. So as many now as 828 million people in 2021 were affected by hunger. So crops are continuing threatened by pest and disease that can, without preventative action, significantly reduce crop yield and food quality. The situation is getting worsened by changing climate patterns that allow crop damaging pests and disease to appear in regions where they were not previously being a problem. Therefore, the seed sector has optimizing productions begins with elite genetics and protecting plants from pests and disease. This is sometimes accomplished by breeding pest and disease resistant varieties, thereby protecting the crop through its growth cycle. But also, breeding alone, we know, cannot address all the agronomic challenges faced by the farmers, which means that crop protection products, like the chemistry that we use for seed treatments and for foliar treatments, are often needed to be able to have a good crop management. In the case of seedborne pathogens, seed treatments are a highly effective strategy to protect plant health. In some cases, seed treatment is the only reliable method to protect crops. So it's very important that we continue discussing about this very important subject. And I do believe that the presentations we're going to hear today really are going to be able to provide this more awareness and more understanding of why the seed companies and why most of the memberships of the ISF, we are so invested on this, invested on different types of technology that comes on seed, treatments on seed, which is not only specific on chemistry, but also biologicals, and different types of treatments as well for the seed. But also it's important that we highlighted that seeds it comes for the food chain. So it's important to highlight this, the protection to have healthy seed, healthy plants, and also its impact on the food supply chain. Thank you.
Thank you, Rose. And it is nice to have the cooperation with ISF because it takes a lot of interest and a practical interest to this network, and we have to work all together to reach the aim of a better world with a better quality and a high quality food, and high quantity as well, because we talk about the quality, but we need the quantity, as you told in an excellent way. And I also thanks the HISTA, because also HISTA supported us with the inputs, and I thank Ruud Barnhoorn, and I hope to have spelled well your name, and I invite you to have a welcome address.
Yes, Gianfranco, thank you for inviting me as the Vice Chair of the Seed Committee of ISTA, one of the multiple people, of course, working within ISTA to do everything what is related with seeds and trade around the world. Good quality, like Rose already mentioned, is mandatory, of course, for food productions, but not only for food productions, but also for good life on Earth. Let's also think about trees and other plants that are necessary for us to all live and have a happy life. With the seed treatments, we see that much more seeds every day are coming in which have chemical treatments on them, which makes testing very interesting, but also testing the seeds not only for pathogens but also for germination have sometimes some surprising results during testing. So it's very necessary that we get more understanding on all these treatments and how the effect is on the testing of the seeds prior to trade. We all see the benefits, of course, for the screen for the addition of chemicals to get better seed quality or soil quality, and prevention of pathogens getting into seeds or giving pathogenic reactions to seeds. But also challenge we see in testing itself is that the chemical compounds and substances might not always give a direct result. So that's something that we have to also focus on within CTELF at least, and see whether we can gain expertise. And then this webinar will definitely support this effort. And again, thank you, Gianfranco, and speakers already. Thank you for your interesting presentations that you most certainly are going to give.
Thank you, Ruud. And this webinar that I hope can follow with other subjects that we defined within the ISPP Seed Pathology Committee. I also thank Gerbert Hiddink and Dorota that they supported us in the organization of the program. And I give the floor. I thank all the people that in the meantime joined us. And I give the floor to Michael Fluken that will have a talk titled Synthetic Pesticide for Management of Seedborne Pathogens. You can unmute yourself.
Okay, excellent. I hope you can hear me well and can see the screen. Okay, excellent. Maybe first of all, thank you very much, Gianfranco, to you and the team and all the members of the International Society for Plant Pathology to invite me as a speaker in this webinar. It's the first time. Maybe a few words about myself. I'm a research fellow from the University of Hanover in Germany, with background in entomology, but also plant pathology, and a few peer-reviewed papers. But 14 years ago, I joined Bayer Crop Science here in Monheim, and since then I had various positions in R&D, mostly with a focus on the field development of products, the use recommendations for product positioning, but also for product registration finally. And this includes insecticides, fungicides, biologicals, chemicals, foliar application, seed treatment products, and various other things. So during the last 4 years, I'm managing a research team doing laboratory and greenhouse experiments in disease control for optimizing product recommendations for seed treatment and soil uses. Yeah, and with this, I like to give it a start here. I'm going to talk about the management of seedborne pathogens in general. After a short introduction about some benefits of seed treatments versus foliar sprays, I'm going to dive a little bit more into the treatments and the seedborne pathogens in the context of biotic and abiotic factors, but also give some key examples of seedborne pathogens and the mode of action. If the time allows, I can also stress a bit the mode of action of certain seed treatment products, show some active substances, formulation products, and then talk a little bit about that is really key. You have mentioned it, Gianfranco, but also the other colleagues, that really here, I think it's still always room for improvement. All right, next slide. Yeah, what are the farmers' benefits of seed treatments? Probably you have seen this sketch here on the right already. So if you treat seeds, for example, that are sown to 1 hectare of land, then you have actually only exposure area of about less than 60 square meters, and you use a relatively low dose rate for the whole 10,000 square meter per hectare. If you do a spray application, typically the dose rates are higher of the active ingredients, and of course you cover not necessarily only the plants, but also other parts of the field, and also the area is much wider. So this is why we see our role in providing hands-on support through seed treatment products that not only contributes to plant health and root health, but also to the emergence and the full crop establishment. The seed treatments can really help to stress resistance and increasing nutrient uptake, but also improve the quality of plants in general. And if you have high quality, you also often have higher yields. And that's in turn, of course, an economic benefit for the grower with a greater profitability, faster rate on investment, but also very important, the economic, ecological, and societal sustainability. That's an important part in these days. So let's have a look at a comparison between seed treatment and foliar. And we can do this by very simple things. For example, the color. Seeds that are treated have to be colored to not confront them with feed or food. Foliar sprays usually have no visible residues. Formulation must be, of course, here in seed treatment, safe to the seeds, whereas foliar applications, they are safe to leaves. Mixtures are often quite complex in seed treatments, where you have the product, you have a coating, you have a colorant, you have micronutrients, you have biologicals, you have chemicals. And for foliar, it's not always that complex. Again, in terms of application, there's a big difference. When you sow your seeds as a farmer, you need really good flowability. You want to avoid that the seeds are sticking in the machine and clumping. So very important also that there is low dust emissions at all. Whereas for foliar sprays, you want to avoid the blocked nozzles sticking on the leaves. Another point is temperature. Often, and this is very interesting to see, that seed treatments can be done at very low temperatures, even below the freezing point in some countries, if you consider North America or other areas. Whereas foliar sprays typically are done below and above the freezing point. But there's even, I would say, more variables or factors where we can differentiate between a foliar spray and the seed treatment. Think about the timing of the decision-making of a grower. Often growers decide relatively early, before planting and before land preparation, what to treat for seed treatment a few weeks, maybe even months before doing actually the sowing. And in foliar sprays, this is more shorter decision-making time, a few days, a few hours sometimes. Another point of view is the mode of decision-making. It differs because as a seed treatment, you often, if you ask growers, they often talk about insurance. Yeah, they want to be sure that the seed that they put into the soil is really striving for good. So a grower can sleep much better with a good seed treatment package that he's sees kind of as a prevention and assurance, and that is dominating here. Where for foliar sprays is often more kind of reactive manner on particularly weather patterns, on a certain disease outbreak. And of course, the big question, and also I'm sure Jay Ram will talk about this and we can discuss this together today, there is more research that we bring these requirements better together. All right, let's talk a little bit about seed treatment. And years ago, a basic solution was basically a fungicide that was treated on seeds, and this covers seed-borne disease. But then researchers were thinking to expand the solutions to not only target seed-borne disease, but also expand to soil-borne disease, foliar pests and disease. And the latest area in this direct development, I would say, is what we call at Bayer crop efficiency. So that means an improved root growth, better plant establishment through the help of biologicals, of micronutrients, of certain products that help to better bring a crop in the ground and out of the ground finally. That is a bit the involvement over the last years. So let's talk about a couple of key examples. And I like to show you here the complexity of a seed that is planted and where the seedling is struck. Of course, today the talk and the symposium is about seed-borne disease. We talk about fusarium, head, smut, bunt disease, snow mold, and we don't talk so much about other factors that can affect and harm the plant. We don't talk about mycetes at Pythium or Phytophthora or Rhizoctonia, which come a lot from the soil. We don't talk a little about soil pests today, but also in the air, there are probably aphids, sucking pests, Lepidopteran that come and try to harm the plant. And we have also airborne disease. So today we focus a lot about seed-borne disease, but always think about the complex situation. It's not just the seed-borne disease, it's also more. And as mentioned recently, we look much more into crop establishment, into full early establishment, plant establishment, nutrient use efficiency, water use, which all can help and be kind of mitigated through 3 treatments. All right, let's have a few examples. Here on the left, you see the English name of some disease, mainly seed-borne disease, but also the Latin name. You have a short description and some actives that can help to reduce these diseases. First one is a very prominent example for wheat and barley. It's Mycolochium nivalis snow mold. I guess everybody or many of you have heard about it. It affects many plants of cereals. It leads finally to a reduced emergence. You can, if you do studies, you can sometimes even see it from the border of the field. There is an untreated plot. There is a disease. There are many plants missing. But we know we have a couple of good fungicides that work against these. Then another very important disease, mainly seed-borne pathogen, is Tilletia caries. Here you can see sometimes black spores coming out of the harvesters, and they are attached to the seed surface with limited or no internal infection. It's a worldwide occurring disease in many cereals, and some products as seed treatments can help a lot to reduce this. And then we go to the more difficult Basidiomycetes, I would say. By the way, Microdorium ascomycete, Tilletia is Basidiomycetes, and Ustilago also Basidiomycetes. So here on barley, spores are attached to the seed surface, and limited internal infections. Infection takes place already at the flowering, and also worldwide occurring in important cereal areas. And most or only azoles will help to reduce this disease. And then we have the beast, I would say, for wheat and barley. That is a loose smut. Yeah, it's another Ustilago species. It's Ustilago nuda with different forma specialis and varieties, I would say. It's really difficult to control, and usually only azoles and a few azoles are working here to really reduce this disease. You see the blackened ears, they do not really fully emerge from the stem, from the tiller, and yeah, it's very, very difficult to handle this. I'll show you later, because before I come to this, we have still other Basidiomycetes that are also very difficult as a seedborne disease. Here in this case, Tilletia controversa can also be soil-borne pathogen, very similar to Tilletia caries. Another example, difenoconazole, can really help to reduce this one. But let's talk a little bit more in detail about the infection and about a seed. So this is a sketch of a seed kernel. It's wheat, and here's still the glume attached. That's a palea inferior, I would say. And if you see the different layers, and we come to this also for the disease that are infecting the seeds here, they can enter different layers. Yeah, after the glume, that is hopefully and should be removed in the cleaning process, you have the pericarp and the seed coat that is here in number 2. Then you have the allurean layer that is covering the endosperm, and here is the embryo, the little plants living and yeah, sleeping, I would say. Some varieties have more or less some hairs here, I would say a beard. And then let's talk about these that can affect and that can grow into the different layers and into the different parts of the disease. Some I've mentioned already, but here a little bit more in detail. You see, Cochleobolus sativus, the causal agent of root rot and foot rot in beet and barley, it's typically only growing in the outer layer of the seed. Then, and this is depending on whether, mostly on the time of infection, Ustilago hordeae, Ustilago hordeae avene, you see different forma specialis, typically also on the outer layers. And then you have a couple of leaf stripe disease in barley or in spring barley and winter barley, and then the fusariosis. The fusariosis can already grow much deeper if the time allows, and if at harvest you have, I would say, a long period of wet and rainy days followed by sunny days and warmer temperatures, but always in the change. And this is excellent for the Fusarium foot rot and root rot to really grow into the deeper layers. And that's very difficult then to get rid of it. Another species that I've mentioned before, Tilletia caries, Leptosphaeria, Septoria, seed blight and wheat, another Pyrenophora, avene, leaf spot in oats and barley. But then again, the most difficult disease, I would say, in terms of seedborne disease, these are the loose moths in barley and wheat. We have also sometimes Ustilago avene, that's in oats. It's very close to the surface of the embryo, but really, if you have treatments that are targeting the embryo, then you need to make sure that they are really not harming the embryo, but killing the fungus. This is a complex slide, but I think it's quite important when we talk about seedborne disease. And let's go one by one, because then it's getting clearer. Let's start with number one here, the flower infection. You see here the development of wheat, barley in this case, with long grains here. And at the time of the flowering, these are the BBCH codes of growth stages. At the time of flowering, Ustilago can already infest. And the spores, they land on healthy plants, and the mycelium is growing into the developing embryo, into the developing endosperm and the seed coat. So here, in terms of control options, typically we only have systemic chemical treatments that really show good efficacy. One of the products, for example, tibuconazole, nice control, had a good dose rate, and proteoconazole. Later in the season, when the corn and the seeds on the field are maturing, you have the option that other disease come and infest the ear. Often here the spores infest the kernels and the glume of the ear. And the time of attack can determine if the spores adhere more externally or grow more internally. We have seen it just with all the Fusariosis species that are there. And that allow, if you have very favorable conditions for the pathogen, that allow the pathogen to grow inside. And here we have a couple of alternative treatments that can help to reduce the infestation of disease on the seed. Because typically most of these diseases here, they adhere with the spores to externally. That means contacts, fungicides, or alternative treatments for seed disinfection can do a good job. I'm not sure if you've heard some alternative treatments like electronically charged seeds. There are companies like Eventus, Evonta that we did some studies, and we see, for example, that snow malt, Microdopum nivale, had a low to moderate efficacy with these treatments, whereas Tilletia caris had a really good and high efficacy. Also here, some alternative treatments can help to reduce this, the seed disease. You also find that many other things have been tried to do disinfection, to do seed sterilization. Among them, there were ultrasound for nanoparticles, UV light, dry air, hot water treatments, hot wet steam technologies, for example, by companies like Roa Petco's Thermoseed, but also, various different forms. So they have some efficacy, especially for these pathogens that come at the time of the ear or the seed, and that they infect mainly here in the outer areas. If you consider chemical fungicides, you could use for surface sterilization, for example, trifloxystrobin or other products. This is a bit the speciality of seedborne disease, the time and the place where they do the infection. But of course, don't forget, there are more. There are all the soil-borne disease that can come from the soil, especially if you have short crop rotations. But there are also airborne disease where seed treatments can help. I'm not going to go into the details here, but this is the complexity that I've mentioned in the beginning, that is more than just the seed pathogens, seed infested pathogens. So let's talk about the bloody beast Ustilago. And here I would like to show you a little bit about the life cycle let's start here when the ear is infected. Yeah, you have from a nearby field maybe black ears. They are sporulating and spreading the spores by air onto freshly emerging and freshly flowering seeds, wheat here, and then they are going to sporulate, and they grow. They grow inside the embryo. You may see it here. You get the presentation in the slides later on. Then you can see that here are some structures that should show the mycelium inside the embryo. You cannot see it from the outside of the seed if it's infested or not. You need to destroy the seeds, and that is what we do. In my lab, I had a very good student, Ariana Del Papa. She was working on Ustilago. Here you can see some of her pictures. We had some seeds that were non-infested embryos. And then you can see here the mycelium. This is exactly what I've shown here in the sketch. That is the mycelium that is colored here and growing inside the embryo. And only later, it's a hidden life. It's always here in the apical meristem of the developing plant after sowing. And then it's coming out a bit earlier, I would say. And often the ear is not fully emerged. It's a bit smaller, I would say, the plant in general. But then you have sporulating spores, and then the cycle is completed. That is a very simple one. If you want to have more details, please look up into literature. This is another picture from my lab here, because we want to test treatments, biological, chemical alternatives, how they can deal with highly infested seeds. And you see here all the little black ears here that are emergence. They are infested with loose mud on some wheat. We have a very special wheat, spring wheat variety, and we can get infestation up to 95%. It's good because then we can use only a limited number of seeds to be treated and can cope with low amounts of products. All right, so let's talk a little bit. This is just one slide where I would like to show you a bit the development in the regulatory areas, the chemical seed treatments, and what the growers probably respond, how they cope with products that are no longer available or taken from the markets or things like this. So some trends maybe. And maybe we could start, some 40, 50 years ago, there were only a few companies, let's say a handful of companies that were able to deliver high quality seed treatment products. Some active ingredients have been taken from the market. And the consequence is, at least in part, that some growers tend to increase demand for high quality seeds that they buy, that they use less seeds that come from their own farm. I'm talking today a lot about broadacre crops, cereals, corn, but maybe we have here an example also from vegetable seeds. Maybe let's have one from spinach. Many spinach growers, they keep asking to the manufacturers, to the seed providers, I want to have certified disease-free seeds, spinach seeds. But the manufacturers cannot provide these seeds because they cannot guarantee that the seedborne disease may flourish. With modern molecular technologies, you may find some traces of DNA that are coming from different pathogens inside the seeds. But the big question is, will these seeds be attacked from the pathogen or not? And will it come to an outbreak? So this is a little bit the trend that I see, this more demand for high quality seeds, certified seed treatment, disease-free seeds. Then there is also a trend that there's a lot of shifts in cropping pattern. For example, winter wheat, the sowing time is delayed more and more. Some growers in Great Britain, they also plant the winter wheat only shortly around Christmas. What we also see that there are many more and much more diverse products coming to the market. And that is interesting because that's a change from, as said, 20, 30 years ago, where only a few companies were providing seed treatments. Now we have combinations, microfertilizer, coatings, biologicals, and we have also to say that the mobile seed treater equipment, here's just one example, is getting much better in quality. Just another example here, insecticide treatments were taken from the market. They were no longer authorized by the EU against virus transmitting aphids. And here you have, for example, the sketch similar as before. It's a barley plant, and often in autumn, before winter time, you have aphids that come to the crop and that attack the seeds, and they spread the virus, or they can spread the virus. And then now the growers take a foliar spray up to 3 times in winter barley before winter to spray this. And then if you imagine the full field and there's only little plants coming out of the ground with pyrethroids, they are cheap, but they are broad active. So they are desperate, the growers. They just want to get rid of the aphids, but there is no treatment, no seed treatment that could protect the plant for a long time inside the plant, just where it's needed, without spreading side effects on non-target areas. Gianfranco, maybe I pause here for 1 minute. Are there burning questions for understanding in the chat, or can you tell me why these red figures or lines are coming up?
Take up, I don't know if somebody did something. Go on.
Okay, thank you. So we can also take the questions at the end of the presentation. So let's talk a little bit about the action and the mode of action for seed treatments. And I think if you talk about seedborne disease, you should be aware of the FRAC, the Fungicide Resistance Action Committee. And they are publishing these mode of actions here. Yeah, you have a nice, colorful picture, I would say. You have different mode of actions. Some chemicals have under mode of actions. We have biologicals grouped here with multiple mode of actions. We have host plant defense inducers, which can be chemicals, which can be biologicals. And you have 2 large groups, which I like to talk about today a bit. And the one is here, the C. This is all the compounds and actives that are targeting the respiration of fungal development. And the other one, I like to stress a little bit more detail because they are so important for seed treatments. These are actives that work on the sterile biosynthesis. They play a key role. And you also see from the market side, which is not only seed treatment, of course, but also the foliar fungicide market in total, a large portion is taken up by respiration and by these sterile biosynthesis inhibitors. I'm not a chemist, I have to say, but I think it's important that you may understand a little bit about the structure, activity, relatedness, and relationships of certain mode of actions. Here in the big group, we have the triazoles. These triazoles typically, and all the azoles in the G1 DMI group, they follow this rough structure relatedness, I would say. You have a main lipophilic compound or part, which is typically an unaromatic group. It can be like this one or even longer. And then you have a second lipophilic group, which is typically smaller, shorter, and rather bulky. In the middle, you have the linker, and often these is containing an OH group, but not necessarily. And then you have this, I would say, tail here, which is important because it can bind to ferrum or cytochrome C. And for non-chemists like me, I would say we can easily see this relatedness in the structure with a rabbit ear model. You have a long ear and a shorter, bulky ear. And these compounds, if you look close enough, later when you have the slides, you can see them and see that this is the structural lateness here. And then let's talk about the mode of action a little bit more in detail. The mode of action is sterol here, that is inhibited. Sterols in general are very important. There are in all living organisms and cell looking after the cell membrane fluidity. And I hope it comes through. You may see it on the picture. It's moving. This is an example for cholesterol that is important for animals. And it's rafting, it's floating through the membrane. And this is important that the membrane is mobile. It's important in the cells. It can help to compartmentalize important cellular processes, for example, signal molecules or governing the fluidity and the protein trafficking. Generally, often we have the complex of 3 to 5 more sterols in the surrounding bilayer. And just here for the fungi, because they are so important for seedborne disease, the ergosterol, this is this compound here. This is the main sterol complex in the cell membrane, and it's following the terpene pathway that is elucidated here. And the mode of action is really the inhibiting the biosynthesis of this ergosterol at the C14 demethylation. So for non-chemists like me, and I think it's quite complex, but we can also make it rather easy. Yeah, if you have Septoria here, you have an untreated mycelium, and it could be compared like a wonderful, nice border. And then if you would treat with a DMI and azole, that would cause a destruction of the mycelium, and you can see the it's no longer fulfilling the action. All right. Then let's quickly talk a little bit about some of the active ingredients, the soil bioavailability. I've listed here one of the other important group that is looking after a respiration of fungi. In pink, you can see the SDH inhibitors. They are targeting the enzyme of SDH, the succinate dehydroxygenase. And this is important for the functioning of respiration. But what I want to show here with this slide is that although all these products are important in seed treatment, the water solubility and the log P value at pH 7 varies a lot. Yeah, you cannot just say if you find this compound, it has a high water solubility and a relatively low log P value. Is it worth testing it for seed treatment? You need to test, because with a clever formulation, you can make substances available, whatever it is. Is it a biological? Is it a molecule? And then you need to consider, I would say, 3 major parts here: the root, plant, and seed uptake. And here you can help with adjuvants in the formulation recipes. Of course, log P and water solubility of active substances are important, but you can adjust this. For the stability in the soil matrix, the DT50 values, soil dependent, are important. Also here you can do pelleting, coatings, formulation improvements. And finally, the soil distribution. You look at the KFOC values. Also, this is soil dependent, and log P. Here you can play a lot with adjuvants, formulation recipes. For me, it's important that often in these days, everybody wants to model and predict things. But if you just look at the variability of water solubility and log P values, don't panic. You can do a lot with a clever formulation. Just to show a few of the key brands and products that are available in the market. Fevea, for example, is prothioconazole. It's important fungicide for head smut and fusariosis. And it provides a powerful protection for various wide range of disease, corn, soybeans, cereals. And it's good for its long-lasting and protective and eradication action. Yeah, and then of course the properties of these active substances are important as you look at the pathogen to fully control it. But it's not just outside of the seed surface. It's as soon as there's water and moisture available, it's penetrating into the seeds and helping to be absorbed through the germination. But there are many, many other products, and often, although there are large competitors like BASF or Syngenta, we also at times partner in order to exchange products. These are products here that, for example, the Radigo M is from Bayer. It's metalaxyl prothioconazole mixture, which contains a good control against fusariosis, but also pythium. Maxime Quattro, Maxime XL, a good products from Syngenta. Just to name a few, it's a complex, the Quattro is meaning 4 active ingredients here inside, and it's a broad range, controlling broad range of different disease. Sestiva from BASF contains mainly floxapyroxate, also for some important disease, just to mention a few. And then at the end, I would like, and I hope the time is still okay, talk a little bit about the quality of seed treatments, because that's a very important point in the whole process. When you release chemicals, biologicals, or micronutrients into the environment on the seed. This is, if you come to Monheim, this is one of these excellence centers, I would say we have. There are many more throughout the world, Argentina, Brazil, very similar. On the one side, we have the demonstration of how we do seed treatments under normal practical conditions with all the funnels and things to do. And then you have also the conference centers, little ones, in order to learn and exchange. Because seed treatment actually is a people business. You have to be passionate about what's going on above and beyond the product portfolio. You have services, you have technical support to farmers, to retailers, to different companies. And that's why it's so important to bring the people together. It's not just a product that you put through a registration on the market. It's also wealth of service, the training, how to treat seeds, the troubleshooting if something is not working, and then also the equipment support and assessment of the seeds. Yeah, let's take a quick look here in the quality. I'm not going to read everything because I think we're short in time. Let's talk about the quality, and this seed treatment quality is affected by many different parameters that you can see. I'm talking about dust, I'm talking about visual appearance and these things, but what is also important, and it all starts with the seed material, purity, cleaning. These are many steps which are very important, dust-free, organic things. Then the product that you want to put on the seed, whatever it is it a biological, a plant extract, bacteria? Is it a chemical? Is it a micronutrient? Whatever, you need to have a good, high quality product, concentrated, safe to the seed, easy to apply, and of course, some shelf life, especially for liquid products, is important. Then the equipment, what kind of treater type do you have? Do you have a more continuous treating process or a batch treater? Monitor this treatment process. Of course, dosing is often given with the product recommendation, and operator safety is also mentioned. Then seed treatment recipes and processes. It is a liquid formulation, many different colorants, coatings, adjuvants. I've mentioned it before, and that they are important and they can help to bring and take the most out of a compound. All right, so we haven't talked a lot about oilseed rape. So let's treat here a process like an example. Oilseed rape, when you have the seeds, they come from the harvest, they are already pre-cleaned. And if you remember the slide that I've shown, we have the seed, the wheat seed with the kernel and the glume. So this is the first cleaning step. And cleaning is so important when you talk about seed treatments. Of course, the moisture content is important. It should be below 8% in oilseed rape here. And then another cleaning process of the seeds. We don't have the product yet, yeah? We just clean the seeds and clean. We have sieves, we have graders to remove broken and other seeds. And then you often have another cleaning line, removing anything that wasn't really captured in the first line. And of course, at the end, dry again and clean. And then you do the actual seed treatment. I show you a little movie later on, and then bagging and dispatch. All right. So I hope that you can see the movie. I'm not sure if you can hear the sound.
Yeah, we are looking at it. It works.
So the proper vegetation is really important here. The time is depending. And then this is a batch treater. You add oilseed rape seed. And start. And here you can optimize the recipe as well. And the fluent powder. And you can empty that. So this is just a short movie in order to see how it's done in real time. And a lot can be done through recipes. And this is, yeah, not the last, but very close to the last slide that I have today. Often you have a product combination. You have a biological product, for example, that is colorless. You have a product which is probably chemical. Then you have a coating that could be colored. And then you have the fluency powder. And the fluency powder is here exactly the last, the final step. In this case, it's just shiny, no color. And then you try to adjust when you have different products. Where do you put the color? Is it in the outside, in the fluency powder? If, for example, products are colorless, a coating or adjuvants are colorless. And then you can see just at the end, the colors coming and coloring the seeds. Same for the recipe 3, just an example, product A could be colored. Often we have it with biological product that they have an inherent color. And then we adjust these other products that are co-applied or as a mix. And finally, on top, the fluency power that is either equally colored or colorless. This is so important in order that the fluency power is binding the excessive moisture, that there's no clumping in the seeds. And also here, the fluency power in the second recipe example is bringing a lot more color that is important. So it's not just moisture content low, but also the color that is added. And then if product A is colored, it will finally drive the color, and then you have a very different overcoat with a different color or a lower flexibility here in coloring. So these are all aspects that you should consider. And then there's one very important parameter, the Heubach dust value, that is measuring the dust of particles. And then you have basically some calibrations here, 0.01 gram per 700 kilogram seeds, 700,000 seeds, it's 2 kilogram oilseed rape. And then you have, if it's below this value, it's really super good. But if it's going higher, then there are certain authorities or requirements that needs to be fulfilled. If that's not the case, you need to change your recipe or your treatment process. And we at Bayer, we not just measure this once in a sample, we do it very often repetitively, at least 3 times at a time, followed by another storage time, and then do another experiment. So really, the colleagues in the seed treatment area, they do Heubach dust meter test basically every day. Yeah, that's the final slide. And I've listed here again a bit the seed treatments, because I believe whatever the seed treatment is, it can be really a powerful, efficient way to help farmers grow healthy crops in a useful and sustainable way. Why is it good for plants? Because plants are very vulnerable very early in the season. They can be attacked by disease, seedborne disease, that fly, insects that fly, or that are airborne disease also. And finally, what is important for the grower, but also the plants, that they are healthy and deliver reliable yields. Why is it good for the farmer? I've mentioned it before. The farmers, if you ask maybe 80% of the growers, many say prevention is better than cure. Cure means, yeah, I have to react. Prevention is like an efficient insurance, and that is good for the farmer. They can sleep much better. It's reducing the need to handle chemicals, dispose containers on the farm, less reliant on the weather conditions. Is it good for the environment? It depends, I would say. I think in most cases, yes, because if you compare a spray, and I've also showed you some examples here during the slides, the spray is usually not that targeted as a seed treatment, and it can have side effects if it's not on the target application. It's not on one point, one time, and one place. So I believe seed treatments generally can help if they are used appropriately as intended. Yeah, and with this, I'm coming to the end. I would like to thank you very much for your kind attention. I leave my email, but probably you better approach me for certain questions for LinkedIn. And yeah, I'm looking forward to your questions and for the discussions. Thank you.
Thank you, Michael. And several, you can relax a little bit after your exhaustive presentation. Several questions already were in the chat, but so you can have a look. But I will leave the floor now to Jairam Lamichan and be back to you and to both of you with the question after the Jairam's talk. Thanks, Jairam, as well for sharing your thought in this presentation that is complementary to the one of Michael. So the floor is yours.
Thank you, Gianfranco. Can you see my screen?
Yeah, you can go on full screen.
Yeah. Is it fine?
No.
I'm coming. Yes. Okay.
Take away duplication. Very good. Excellent.
Thank you, Gianfranco, to you and all other colleagues organizing this webinar. And thank you also for inviting me to give this talk. So I will start my talk with a very short introduction of myself. So I am a researcher working at INRAE, which is the French National Institute for Agriculture, Food and Environment. And I work at the interface between agronomy and plant pathology, both on issues related to crop stressors, so both abiotic and biotic stresses affecting mainly crop establishment and productivity, of course, mainly on field crops I work on. So today my focus will be mainly on field crops and on soil-borne pathogens. That is also good because Michael has provided a lot of details about seed-borne pathogens, and I'll be much shorter than Michael because my idea here is just to provide you a general overview about fungicide seed treatments, and mainly I would be talking about benefits versus risk of this practice. So I start with a very short history about fungicide seed treatment. Oh, it doesn't work. I don't know what. Okay. So fungicide seed treatments is an old practice that consists in treating seeds with one or more fungicides, mainly when we talk about controlling plant pathogens, mainly oomycetes and true fungi. Then this practice is quite old because it was began with cereals with the use of brine in 1637, followed by the use of arsenic in 1755 and copper sulfate in 1760. But nowadays, there have been a lot of advancement in the types, formulation, and application methods for fungicide seed treatments. And Michael has provided a lot of information already in this regard. So just to show you how treated seeds look like compared to untreated seeds. So these are seeds of carrot, which are untreated. And when we talk about seed treatments, actually we may have different forms of seed treatments. For example, these are the same carrot seeds treated via dust application, or we may also have in some cases seed pelleting. We generally talk about seed treatments, but seed pelleting is done mainly for different reasons. For example, one of the reasons is when we have to plant seeds that are very small in seed size, and they are quite complicated to plant with seeders. So in order to increase the seed size, we may do pelleting with or without integration of chemicals, or also starter fertilizer to increase seed and seedling and growth vigor. So when we have seed treatments and a lot of treated seeds, these seeds generally have a color, and actually the dyeing process of seeds is a process where colors are added in addition to fungicides for different reasons. The first is to differentiate between treated seed lots from the non-treated one, because farmers may
sorry, Jairam.
Yeah.
There is somebody that wants to register. We are already registering the webinar, so we will place on YouTube later. Okay, thank you.
Okay.
Please go on.
Yeah. So the addition of colors are done to differentiate treated seeds from non-treated seeds, because we may have different seed lots of the same variety. So we have to distinguish those seed lots or brands sometimes. But seeds are treated also to alert farmers and others handling the treated seeds that treated seeds cannot be used for animal feed, because if we cannot distinguish treated from untreated seeds, then we may confuse and use for feeding purposes. But the addition of colors are generally done also to facilitate cleaning operations in the case of an accidental spillage. For example, during planting treated seeds in a field, farmers may have some accident and the seeds can be poured down in the soil. And in this case, we have to collect these seeds, and when they are colored, it is much easier to collect them back. Or also make treated seeds less attractive to birds. For example, when there is an accidental spillage, birds may come to eat these seeds, but when they see that they are colorful, actually, they are not very much attracted compared to untreated seeds without colors. So who perform fungicide seed treatments or seed treatments in general? It could be seed company, and the most important seed companies that perform seed treatments are Syngenta, followed by Limagran and Bayer. It could be seed distributor such as Vilmorin, BASF, and Syngenta again, or the farmers itself. And it depends really on crop species, farm size, and planting time. And why we do seed treatments and fungicide seed treatments in particular. As Michael already told, for different reasons, in particular to limit risks of seed and seedling damages due to seed and soil-borne pathogens that cause a disease called damping off. And when we talk about damping off, it can be caused both by seed-borne pathogens or soil-borne pathogens. And while the use of certified seeds can prevent attacks or the development of damping off due to seed-borne pathogens, we cannot control soil-borne pathogens by only planting certified seeds, because these pathogens live in the soil, and when the environmental conditions are conducive, they attack the seeds or seedlings. So we have to perform seed treatments in order to control soil-borne pathogens, which are, by the way, the most important challenge for farmers under conducive environments. But fungicide seed treatment, as other seed treatments, is also an insurance for farmers, especially under high-risk situations, because as I already told, when there is an inoculum of soil-borne pathogen in the soil and the environmental conditions are favorable for this pathogen, they can lead to complete or partial emergence failure. And in this case, farmers will lose all his income. And when seeds are treated with fungicides as a preventive method, it can at least partially control these soil-borne pathogens. So lower risks for farmers in this case. But also because seed is expensive and protecting that investment is facilitated when high quality fungicide seed treatments are done. And of course, in some cases, the ability to reduce seed-borne inoculum over time makes fungicide seed treatments popular among farmers. Michael has already talked a lot about this, but what is important to know is if we do not treat our seeds and we plant these seeds especially for cereals, when we will harvest the next season seeds to be planted again for the first generation. In this case, these seeds may have a higher inoculum of seed-borne pathogens causing problem on cereals, as Michael told before. So when we treat seeds, we can reduce these risks due to seed-borne pathogens. But fungicide seed treatments are mainly useful also to control soil-borne pathogens, as I already told, and these pathogens cause two types of cause damping of disease in two specific crop phases. So we talk about pre-emergence damping off when these pathogens attack mainly the germinating seeds and cause necrosis or rotting of seeds before they emerge. Or we may also have post-emergence damping off. And in this case, soil-borne pathogens cause a complete wilting of already emerged young seedlings, leading to complete or partial emergence failure or crop establishment failure. But fungicide seed treatments are also very useful to control airborne diseases. Again, Michael has provided already some hint in this regard. And in this case, we use systemic compounds such as triazoles, and these products are quite interesting because they last longer than other contact fungicides, and they are really useful to control airborne diseases such as powdery mildews or rust on cereals in general and on wheat in particular. So which are the types of mobility of fungicides used for seed treatments? The first, we talk about contact fungicides when they are used as surface protectants that target seed, surface-borne, and soil-borne pathogens. So they are generally effective up to 4 or 5 weeks from sowings. The second group of fungicides are locally systemic fungicides, and they target both seed surface-borne and internally seed-borne pathogens, and their effect lasts a little longer than the first group, so a few months after sowing. And the last are xylem mobile fungicides, which are very effective against soil and airborne pathogens, and their effect lasts even more longer for several months, as they are systemically translocated throughout the plant. So what is important here to know is there are fungicides that may have more than one type of mobility, and they are very useful to control different kinds of pathogens affecting seeds and seedlings. So which are crops that are concerned by seed treatments, actually all crops, both arable and non-arable crops, and this is the case worldwide. In particular, in France, almost all arable crop seeds are treated, but the share of seed treatment differs from one crop to another. For example, sugar beet seeds are the most treated one, as you can see in the figure, while soybean seeds are the least treated, because on soybean we have less problems related to seed and soil-borne pathogens compared to many other crops such as sugar beet, wheat, or maize. And the situation is very similar in the US, where corn is the most treated crop in terms of seed treatment, while wheat is the least treated. And also in the US, the share of the surface sown with treated seeds has been increasing over the year. This emphasizes the importance of seed treatments to control seed and soil-borne pathogens. So just to list some benefits due to fungicide seed treatments, the first is, of course, cost effectiveness compared to broadcast pesticide application. Michael has already talked in this regard. The second is user friendliness, as the use of seed treatment products reduces the need to handle chemicals on farm unless the farmer does seed treatments by himself, as I told before. Less or lower reliance on favorable weather conditions in terms of field access compared with foliar spray application, because foliar spray application is possible only when weather conditions are very good, neither too hot nor the presence of rainfall, etc. But since seeds are treated before planting, it is much easier to plant treated seeds even when weather conditions are not the perfect one. Lower environmental pollution compared to in-furrow application or aerial sprays. This is another important point, because the quantity of pesticides applied via seed treatments is much lower. The first thing. And the second thing is that treated seeds are localized in the soil, so only the spermosphere is concerned. So it is really interesting in this case. But fungicide seed treatments have also some limit. The first drawback of this practice is that there is no obvious economic returns for farmers, because the effectiveness of fungicide seed treatments is very variable among locations, sowing dates, sowing rates, crops, and years. But this practice has a cost for farmers. So while the cost is constant, the return in investment is not sure. And this is, of course, a drawback of this practice. The second drawback is development of resistance by soil-borne pathogens. And this is mainly because often the same fungicides with the same mode of actions are used for seed treatments. Although there is a number of fungicides, the most used fungicides are very similar worldwide. For example, metalaxyl or mefenoxam are often used to control oomycetes such as Pythium or Phytophthora, while fludeoxonil and a few fungicides are used to control true fungi causing dumping up, such as Fusarium or Rhizoctonia. But still, it is important to emphasize that the risks of resistant development is lower via seed treatments compared to aerial treatments, because the number of application is only one seed treatments via seed treatments compared to many aerial sprays in a single cropping season. Another limit of fungicide seed treatment is exposure risks to operators. So it could be a primary exposure while treating seeds. As Michael told before, dust emission is it could be a problem when the quality of seed treatment is not very good, and in this case, the person performing seed treatments may be exposed to primary exposure, and the secondary exposure also is a problem while manipulating already treated seeds, because also in this case, dust inhalation may occur when pouring treated seeds into planters or handling leftover seeds. Negative impacts on non-target soil organism. Michael already mentioned very briefly in this regard, and this is also a limit of this practice because while we use fungicide seed treatment to control soil-borne pathogens, actually soil is very rich in many macro and microorganisms. And actually, they provide many ecosystem services for plant growth promotion and also productivity. And when we introduce fungicides via seed treatments into the soil, fungicides may affect these organisms. This could be macro or microorganism, and there are quite a lot of recent works in this regard, but I'm not going into detail of that. Another problem is, in order to increase benefits due to fungicide seed treatments and limit risks related to this practice, there is, of course, a number of recommendations to be followed. And the first is that we should respect very strictly regulations while handling pesticides. In this case, of course, pesticide treated seeds, and this is not always the case because here in France, we have conducted a national survey of farmers in order to understand their risks and perceptions about pesticide treated seeds and also their knowledge. And actually, we have found that most farmers, they do not pay a lot of attention while treating seeds or manipulating already treated seeds because they do not wear protective equipments such as gloves or masks that they should do according to regulations. So there is still a lot of work in terms of awareness raising of these farmers. The second point is we should limit or avoid use of treated seeds when disease risk is low because the risk of damping of development is very variable, merely depending on weather conditions. But most often, the planting of treated seeds is systematically done independent of the risk situation. This is especially the case in Europe, but I suppose that this might be also the case elsewhere. The third point is we should have prior knowledge about key potential soil we may have a field where oomycetes such as Pythium and Phytophthora may be problematic, and other fields where the true fungi such as Rhizoctonia or Fusarium may be problematic. But if we treat seeds less sense, and we should be focusing to the target pathogens that may, of course, reduce cost of seed treatments and increase the effectiveness, of course. Use of best cropping practices is another point. For example, the use of tolerant varieties to soil-borne pathogens, adaptation of sowing dates, and precision planting. All these practices may help reduce the risks of the risks or drawbacks of fungicide-treated seeds and increase the effectiveness and benefits for farmers. And the last point is we need a more closer collaboration between public research and the seed industry to make a judicious use of fungicide-treated seeds so that farmers may get more benefits and occur lower risks due to this practice. So with this, I have finished. So most of the information I have presented here are taken from this review that we have published back in 2020 in plant disease. So if you are interested to know details about what I have said, please just have a read this paper, and I would be very happy to take some questions if you have. And with this, I thank you for your attention.
Thank you, Jairam, for your very good presentation. And I'm sure that a lot of questions will come to both speakers. And we can, I may, since there are no addressed questions, I may take the same questions to both of you. So let's start with Michael and let's move to you, Jairam, about the effects, or if there are data or not, of the seed treatment on the microbiome, on the soil microbiome. Do you have enough data? Do you have data? Which is your opinion about?
Yeah, maybe I can go first. Thank you. Thank you very much for the question. I've tried to answer in the chat, but I understand that we should discuss here a little bit, and we will discuss all the questions in the chat now. Thank you for asking and rephrasing this question, Gianfranco. So me personally, as I'm running a laboratory here in efficacy that is mostly looking after performance and efficacy, we're working not for the safety of our products against earthworms or soil microbiota. In this particular division I am, but I have the colleagues here in Monheim. They are looking at the ecotox and all these environmental safety aspects of chemicals, of combinations with biologicals, and all the colorants and adjuvants that you may think of. Of course, microbiome is, I would say, a relatively recent area that is much more investigated now, and I really appreciate that a lot is going on. Also in my team, we are looking at microbiota in connection with some products, chemicals, but also biologicals, and how we can interact here and get better to a better crop establishment and use the potential of the soil that is there already in the field, so that no additional interference is needed. So to come back to the original question, I think I don't have at hand right now some data or some published work, but of course, I think it's important, and me probably in the future will also follow up more on this thing, so I can also connect you to further colleagues. But once again said that the chemicals that are used, they go through a very rigorous registration. And in this registration, a lot of studies are required. And I don't know all the details of the studies. I know that compatibility or no effects against earthworms is one key aspect. I don't know how much microbiome in general is included here, but I could think that there is more and more demand coming from authorities in the future.
Thank you, Michael. And before to give the floor for the answer to Jairam, I can tell you two things. One is that we will have a meeting in ICPP 2023 in Lyon at the end of August, organized by our committee, and it will be moderated by Lindsay and by my So you will be here. You are invited for the people that are there to be part of this meeting that will be related to. The second one is that in case any of you needs an attendance certificate of this webinar, at the end of the webinar, we will place into the chat the email address of Lucrezia, and you can ask her with the subject request of statement of attendance, and we will provide you. Thank you. Jairam, do you have a feeling about that, about the effects on soil microbiome of the seed treatment?
Yes, as far as I know, there are some studies showing that there are some negative effects of seed treatments with fungicides or the other compounds on soil microbiome, but more specifically in my case, I'm running 6-year field trials across very contrasted environments, and among different variables I look also at the impact on soil microbial diversity. So this is the 4th year of the project, and I should say that the results are very variable from one year to another, and it's really difficult to interpret the results because it seems that sometimes we have very inconsistent results, because sometimes we have a positive effect, even positive effect of fungicide seed treatments on alpha and beta diversity, and sometimes very contrasted results, the opposite. So we do not really know how to interpret, but we have to go into details in terms of statistical analysis by including other 2 years of data in order to draw robust conclusions. So quite difficult to make a general conclusion in this regard.
And maybe I can add to that, this is not in the area of seed treatment, but it's maybe still interesting because we have done recently a study with the university, and we have there a very excellent PhD candidate who was looking at apple plants, the apple trees. He was taking soil samples from the soil in the root area of these trees after there were disease infections on the apple plants, on the upper parts, and after there were measurements, meaning biological products applying to reduce the pathogens on the leaves, but also chemicals, fungicides to reduce the pathogens. And we could always see in this work that there's a shift and a response in the microbiome on the soil roots. So this is a publication that is coming out very soon. Maximilian Becker from the University of Bonn. Maybe you want to look it up, but it's not in the seed growth area, but it's in that area of microbiome and biological plant protection areas and chemical plant protection compounds. So there is shift. There is often a short time shift to a certain extent, but it's not as long lasting.
Thank you. Thank you. I should have set of specific examples that can be applied to the seeds, but they will be presented in Lyon. So if any of you will be there, it will be an opportunity to follow this kind of talk. One more question by Jerry Mongold, that is a member of ISPP Seed Pathology Committee. He asked, farmers will often ask how long seed treatment remain active after planting. What is your feeling about?
I mean, that's a very important point to know this. I've mentioned the group of azoles today. I've talked a lot about the DMIs, the triazoles and azoles in general. And there are some compounds that can, in a certain dose rate, can last longer than others. So there is variability, although the mode of action is the same. And why is it so important? Because if you consider spring wheat or spring crops in general, you have a seed treatment, and then sometimes relatively soon after, you have a foliar application against another disease that you cannot target with your seed treatment, then you have still some levels of your compound in the leaves, for example, and that could start the pressure on selection towards resistance of certain mode of action. So this is very important, and I think all the companies that produce or that bring certain active ingredients to the market should consider this and should know how long is a seed treatment active. I think it's very important. You can do different sorts of things, very cost-intensive things like radio-labeled, C14 radio-labeled translocation. You apply these specially spiked radio-labeled compounds on the seed. You do normal seed treatment and follow up. Where is it finally? Where is it distributed in the plant? That's very cost-intensive. You can do it with C14 labeled material. You can also do it with tritium. But really finally, the easiest is you do efficacy test, bioefficacy. And that is also what I do here in my lab. We do a normal seed treatment with a compound, the fungicide that you want to know. How long is it active? Is it translocated into the leaves? Where is it active? Is it in the root zone, or is it just on the seed, on the area where it's treated? Is it there active? This is something you can do. You can do then special applications of the fungus that you're considering at a certain time, maybe 1 week, 2 weeks after the plant is coming out of the ground. This is, for me, I think the most easiest way to show how long a fungicide is active. But of course, you don't need to necessarily to work with the most important disease in a certain crops. You can also work with model plants, with model disease, with model plants in order to better estimate what is left. You can vary the artificial inoculation. You do a high inoculum, a low inoculum. You see, is there still bioefficacy there?
Thank you, Michael. Jiram, do you have feedback about?
Yes, again, I don't think that it is very easy to reply to this question, but in my presentation, I talked about from a few weeks in case of contact fungicides to several months, but that is the information I have found in the literature. But there are some recent works also showing that actually how long the efficacy of fungicides lasts really depends also on the efficacy of translocation of this fungicide itself. And this efficacy of translocation really depends on environmental factors. So it is quite complex and it is not really easy to respond, I believe.
Thank you, Jiram. Another question to Michael. How long is the chemical seed treatment safe on seed without affecting the viability when treated seed is stored?
Yeah, I mean, that is also a key requirement for products. And we have, I first talk about chemicals here, but later I may talk a bit about biologicals. I can also make it very short. In corn, for example, we require at least 3-year stability of fungicides on the corn, on the treated corn. Yeah, you treat today, you test after 1 year, after 2 years, after 3 years, how much is left? What about the dust? What about all the parameters? That is something we often do with our chemicals. We often have problems when we use biologicals. Biologicals, be it spores from bacteria like Bacillus fulmus, Bacillus subtilis, or plant extract. They react much better. They often react much stronger with storage conditions. So that is sometimes when we work with startup companies that have a great idea about biological seed treatments, but that is sometimes a key requirement that we cannot compromise. Yeah, we need a certain time of stability on the seed when it's stored in the proper place. I hope this answers the question a bit. but it's a key requirement to have a certain stability for a time period on the seed, not just from the treater to the farmer to the field, but often it's longer.
Thank you. Jairam, do you want to add anything?
No idea at all. I don't have any expertise to respond to this question. Thank you.
I thank all the people that interacted because we had a big bunch of questions, so I'm very happy about that your talk induced several different interests. So, okay. I will go over with that. People congratulate with you for presentation, so it's great. And I will be back. Fantastic presentation, very good. Yeah. Why organic ways to treat seed are not opted? And can we please get a glance over chemical and cytological tests? This is a strong question. Michael.
Yeah, I'm not sure if I can really answer this. It's a very complex question. Thank you very much. Of course, organic ways or organic treatments are important, and they can help a lot. I hope it comes in it was shown in the presentation that all the big companies like BASF, Syngenta, Bayer, Corteva, they are not just focusing on chemicals, trying to sell as much as possible. They really see the need that it's a holistic approach. You want a good crop establishment, but you want to have as little interaction, negative side effects on the environment as possible, which is often attributed to chemicals. So all the companies are working in the area of biologicals and of organic ways to help seeds to be protected. But in terms of the topic today, the seedborne disease, I think most important is if you, as a grower, consider how's the condition at the harvest of my seeds. Can I use the seeds from this field here where I'm standing for the next season? Do I need to treat it? If I see the weather is really nice and dry and there is no infection from the outside coming, probably I don't need a chemical seed treatment. I can go with a biological or with even nothing. Yeah, there are different ways of approaching this question. And cytological tests, I think that's a bit out of my comfort zone, but maybe I can approach a colleague that I have in mind doing a lot of cell test systems in a high throughput manner, of course, that could help or better answer this question.
I completely agree with you. I guess that although I don't work in a company, I think that most of the company are working now much more organic compounds and natural compounds than on synthetic pesticides, but being aware that synthetic pesticides work much better than alternative ones. I just can anticipate that in the next months, we will have another webinar on use of biocontrol agents to control seedborne pathogens. So if you follow our Facebook page or our social channels, you can have information about this. Jairam, your feeling about?
Yes, I think that there are really a lot of work ongoing on biological seed treatments, much more than what we can think. And recently, just for your information, Gianfranco, you know that I have made a meta-analysis on the effectiveness of biological seed treatments, and most often they are quite effective, but under control conditions. mainly in under greenhouses, etc., for high value crops. And under field conditions, their effectiveness is quite variable, like chemical seed treatments, but even much high variability. So just to say you that I think Michael can confirm this, industries are working quite a lot on biological seed treatments. So I think that this will be the future in the next 10, 20 years. Also because you all know that in Europe, there is a strong restriction in the use of chemicals in general, and also those used for seed treatments in particular, because the recent news is that the use of metalaxyl for outdoor treatments is forbidden. And Thiram is completely forbidden, and many other products are forbidden in the EU. So there are a lot of works running on biological seed treatments.
And maybe I can add to that, Jairam and Gianfranco. It's absolutely right, and we work a lot on these things also. And I think in this time now, when everybody is thinking about the next generation and how we do farming then, with all the tools we have at hand now, this webinar, for example, Gianfranco, disseminating and sharing information, bringing people together, making people think about certain topics and thinking about the future. I think that's the first step. And then bringing all the professionals together, the growers, the retailers, the producing companies, for example. And this is today much easier through the modern ways of media and sharing information. So this is already a great first step, but much more research and studies have to be done.
I completely agree, Michael. And we are available as a committee for sharing this kind of network, to join this kind of network whenever it is required. Another question. The mix between fungicides plus insecticide is possible effect on efficacy to control fungi and insects?
Yeah, if I may say a few words, it's absolutely true. You've seen the example that I mentioned about product A and product B when it's applied in a recipe on oilseed rapeseed. This is something we often test already very early in the development. It takes 10, 12 years to develop a new seed treatment chemical, for example. And of course, we need to compare where to treat. Is a fungicide the first layer on the seed? Is the insecticide more on the outside? How do they interact? This has been tested, of course, here, partially also in my laboratory. And of course, there are sometimes effects, unwanted effects from the insecticide on the fungicide or vice versa. And of course, as soon as there's something, we raise our hands and say, so this is a no-go, or we stop here, or we continue another way, we adjust the recipe, the formulation, or we need to have another collaboration with other partners.
Thank you. A lot of people congratulate with you for the talk, so we are happy for that. Jairam, about mixing of fungicide and insecticide?
I don't know, at least I'm not aware about this in Europe, but I know that in the US it is quite a lot frequently done for certain crops such as maize or soybean even, but I do not know more details.
Excellent. And now let's have a break for the chat. While in the chat, Lucrezia can place her address, so you can request the statement of attendance, sending an email to her and telling as a subject certificate of attendance. Before to be back to the chat, I give the floor to Kuldeep Singh Yadon for a question.
Yeah, thank you very much. And thank you very much, Michael and Jairam, for this nice presentation. In very brief, you mentioned everything. My question about the farmer's perspective, that sometimes farmers have to treat their seed with fungicide as well as insecticide, and then in legume crops they have to apply rhizobium as well. So sometimes they came directly to us that what should we do? First apply fungicide or insecticide or rhizobium, or first apply rhizobium or then insecticide or fungicide, or we have to take some break. So these things are very common in farming communities. So at this platform, I think this is the right question to ask. So what should be the way to address this question to farmers? Am I my question is clear to you, sir?
Yes. So I'll start responding, then Michael could complement. As far as I know, this is a very good question, because it seems that some of the fungicides used for seed treatments are not compatible with bradyrhizobium involved in nodulation to fix atmospheric nitrogen. And there are some information in the literature in this regard. But in my case in Europe, actually, most legume crops such as soybean, pea, or other legumes are not really treated with fungicide. So we do not have this problem, because we do treat with bradyrhizobium to enhance nodulation. But in other contexts, still I again say that in the US, I had talked with some colleagues, and they told me that in some cases they are incorporated in the same treatment, and that is also the case in Brazil for soybeans. So I do not really know in that case whether there is a problem of compatibility between bradyrhizobium and chemical fungicides or not.
Okay, Michael, can you unmute yourself?
I'm sorry. Yes. Okay. Yeah, I mean, this is very true. There are, I know the case from Brazil that growers are asking when to put bradyrhizobium products on the seed, and I cannot give an answer for all products, of course, because I don't know all the fungicides and insecticides and bradyrhizobium products. But typically, or as a trend, I would say, put the fungicide first. If you have an insecticide or a nematicide, put it in the surroundings. And at the very end, and also best, shortly before you plant your soybeans and do the sowing of soybeans, then only shortly before treat the rhizobium products. That has been tested. We have also done tests with bacillus products in our early research and development, and often this was a better way. So as said, it's difficult, and sometimes maybe you need to ask the local colleagues from the companies that are selling these products if they have some information, but it's not an easy answer. And rhizobium products are important, especially for LATAM, for Asia Pacific. I haven't heard much about US soybean growers that are considering, because they anyway say they have a lot of rhizobium in the soil because they do corn, next year soybean, corn, soybean, often in a very short rotation. Then they believe they don't need to add on purpose extra amounts of bradyrhizobium. But that is just an impression from my personal observations. So it's not an easy answer to this question, but thank you.
Thank you, Michael. And I see that some of you placed your email into the chat. I suggest you to take the email of Lucrezia that placed into the chat and send her an email. if you want the statement of attendance. Another question. No, you don't have to place into the chat. You have to email to Lucrezia, okay, if you want the statement. Another message is that if the seed already infected with fungal pathogen, thank you. If the seed already infected with fungal pathogen, is possible the fungicide can prevent this pathogen from development? Michael.
Yes, in generally there are products, chemical, but also biological fungicides that can help to prevent seedborne pathogens to attack the seeds or the young plants. That is generally possible. I've shown you some examples. Sometimes there are pathogens on the seed, inside of the seeds, that cannot really, that is not surviving. Then you probably don't need a seed treatment. But I think, yes, there are a couple of products that can really help to reduce the seeds borne disease.
Yeah.
Yes, I agree with Michael. In principle, yes, these fungicides are supposed to control the seedborne pathogen during seed germination and seedling emergence.
Okay, very good. You entertained us for a couple of hours. It was a very good discussion. There is anybody else that wants to tell anything before to close? Please raise the hands in case. Or if not, yeah. During seed germination testing, I'm facing issues of white and black fungus despite sterilization of media. How can I stop this issue, Michael? It's quite pretty wide question.
Yeah, it depends. I would say it depends on the crop probably, and yeah. I mean, maybe you can take a look at the presentation later. Do you remember the slide where I showed the reed seed kernel with the gloom? And there are some fungi that can grow inside different layers of a seed. And the deeper they grow, the more difficult they are to target for chemicals, for any other treatments. So if you could be a bit more specific to your case, maybe I can answer better. But in generally, if you have a good chemical product, probably you don't see that anymore. Or if you do a good sterilization, also here I've talked about alternative seed disinfection measures, hot steam treatments, hot water treatments, whatever. I'm not sure if this is helpful. Otherwise, if you work in soil, and this is also what I've observed here in my laboratory, often you have soil that has already or is already carrying some pathogens. And when there is a young seedling coming out of the ground, the pathogens from the soil attack the seedlings. So I think that would be a rough answer to that. If you're more precise and if that helps, that's fine. If not, you can also contact me later.
Okay, thank you. And please, Michael and Jairam, can you upload into the chat the presentation, the PDF for your presentation? And I just tell to everybody that on the YouTube channel of SPP Seed Pathology Committee, this webinar will be uploaded in a couple of days or so. Jairam, do you have an answer to the question?
Yeah, I fully agree with Michael, and I'm sure that that should be the case of cereal seeds. And I suspect that in that case, the contamination is at the embryo level. And in that case, it is really challenging to reach until that pathogens. I would not say that there is no way, but it is quite difficult, I suppose.
Okay. another question by Marwa Momni, that is the secretary of HSPP Seed Pathology Committee. She asked how much seed treatment can reduce foliar fungicide application. Michael.
Yeah, I mean, we've discussed this a little bit. Sometimes you see this extended period and this extended efficacy of certain products. Again, there are differences between fungicide seed treatments. Some have a relatively long-lasting effect and are translocated in the upper parts of the plant, but probably also down to the root tips. I can maybe name a few products or companies that are claiming certain effects. I know something about flupiram at a higher dose rate, then you see a certain efficacy on the upper parts of the plants. It depends for prothioconazole how long this is, but there are certain products that can help here. Again, it's always the question, how much and how long do you like the efficacy before you come probably with a first spray, or before the airborne disease are attacking. And not all seed treatments have the same long-lasting efficacy. So this is something it would be best to ask the producer of the certain product that you may have in mind.
Jairam?
Yes, I fully agree with Michael, and I would not have anything else to add into that.
Okay, thank you, Michael, for sharing your PowerPoint, your PDF. Jairam, if you have the opportunity.
I think I have already done. Can't you see?
Sorry.
Maybe it didn't work.
If you can try again. I think that there is a question.
Do you know how should I do? Because I have just drag and dropped. I can see my PDF on chat, but I don't know if it has worked.
You can see your, yeah, okay.
Just press enter, maybe, or.
Oh yeah. Oh, sorry. Yeah, you are right, Michael. Okay, done.
Okay.
Okay, Muhammad Osnain, do you have a question? I saw that you raised the hand. Muhammad, are you with us? Can you open? Okay. Yeah.
Sorry. Hello, sir. Good night. This session was very informative. I am working as a seed analyst in seed technology lab. We are facing a fungus issue during seed germination testing. The fungus color is black and white. We disinfect or sterilize our not only equipment but germinator and media. But doing this is not. After doing this, we didn't get any good results. The fungus is continuously appearing in cotton seed, pea seed, and somehow it was also appear in treated high corn seed. The fungus color is black and white. I don't know which the fungus belong to which species. Can you please tell me about it? How can I overcome this issue? Hello,
Michael.
can you please?
Again, I mean, I've tried to get already to help a bit. I'm not sure if it really makes sense. If you do verify the sterilization technique, of course, it's a surface sterilization. Once again, the first step is try to clean your seed as good as possible. Remove all the outer layers of leaves, of hairs, whatever is there. I think that can help already to reduce the load of fungal seedborne disease. That's the first and most important step. And then if you're not successful with the surface sterilization in a certain kind of maybe alcoholic solution or so, maybe you can just change that. And try to have different time points, how long you do the sterilization, with what products. yeah, I think that's the only thing I can say from this side here.
I only used sorry for interrupting, sir. I used ethylene as a fertilization of place where I am conducting germination test.
Okay, and this is not successful because you still see the fungal growth in?
Yes, yes, sir. I think the main issue which I found, because I am still not an expert, it's my start of career. I think the main issue, we are not sterilizing media. We are using sand. That's okay. I think that's due to sand. But during paper test, which we sterilize, then why this issue appear in during paper test?
As I said, I think it's a seedborne disease. Yeah, it's difficult to answer here, but maybe you take another look at different seed surface sterilization substances, slurries, vary the length of the seed sterilization, and then try it again. And maybe you find also some answer from the literature. Me myself, I can take a look at what we use here in our laboratories, and I may send you this information later on. But at the moment, I'm sorry, I don't have a better answer here.
Thank you so much, sir. It would be great if you can share any literature with me, as it will be helpful for me to improve my career and learn more about seed, as I have a great passion about it.
Great.
Thank you. Jairam, do you have a comment?
It is not clear to me, Mohammed, whether do you think is it a seed-borne pathogen or coming from sand?
Yes, sir. It's a good. Yes, I think it's coming from sand. If we think that sand is not still live before seed germination test, but if we talk about paper test or petri test, they are still live. Then why fungus appear in paper test and germination test? The seed is not treated with any fungicide or insecticide, but in germinator these fungus spread and also affect the high corn treated seed. The fungus color is black and white. I can share pics with you if you can please share email address, anything else, because I have pics of this fungus.
Is it possible that your laboratory equipments or even the lab is contaminated with spores? Because sometimes in the air there are spores of many fungi.
Yeah.
Could that happen? Because it happened to me once, and I struggled for 6 months to solve this problem.
Yes, sir, you can say it is possible, because everybody entering lab without any permission, that's I think I don't like, but I think you can say.
Another suggestion is, like Michael told, if you suspect that this is a seed-borne pathogens, then I would also test seed sterilization with household bleach, but pure household bleach, or even a different percentage. You can dilute the household bleach at 10, 20, 30% and make sterilization, but I'm not sure if a higher concentration of household bleach has a negative effect on germination power of the seeds.
Thank
I
you.
will try. Thank you, sir.
Jairam, we didn't see your PDF. If you can upload, otherwise don't worry, send to me and I will share.
Not possible. I've done.
Don't worry. One more question, maybe last.
I've done. It is okay.
Okay, don't worry.
There is you can download from the chat.
If I don't see into the chat, I don't know if others see.
Just after Michael's PDF.
No, there is no. At least I don't see. But we will solve.
Do others see it?
No, they are asking. Last questions. Nanotechnology. This is very nice words, not easy to turn in practice. Michael.
Oh, nanotechnology. I'm not a specialist.
But very small things.
Yeah, that's right. I mean, all the things, I mean, today we talk a lot about seedborne disease, and there are many, many ways to reduce seedborne disease that have been mentioned already. I'm not aware about a certain product or product type coming out of nanobiotechnology. And I need to look at the researchers and more at the literature. Not really sure what you mean. I mean, we've worked with RNAi, we've worked with fragments of DNA, of other things. Of course, that's something you could try, but really I'm not the expert here. And I even don't know what is offered on the market in this area today. Maybe Jairam, you know something about this?
Yeah, this is a very how would you say? It is a fashion to work on nanotechnology. So everybody is interested in this, but personally, I'm completely unaware about this technology, its effectiveness, side effects, etc.
Maybe in a few years, we will have another webinar just on that.
Yeah, Gianfranco, can you see my presentation?
Yeah, now yes, thank you.
Because I have just realized that Lucrecia had sent me a message before, and I sent only to her my PDF. I don't know how it happened.
Okay, don't worry, now it is. So we had a very nice couple of hour talk and discussion with a lot of questions. So your presentation raised a lot of interest. So I thank the SPP committee for having this very good idea, and Rose for ISF, and Ruth for and you both, Michael and Jairam, for the excellent talk, and I'm sure that we will have further opportunities of interaction, and thanks to all the people that were interested in our webinar, and this gives us reasons to go home. So have a nice time, have a nice weekend, and see you next time.